All right, so we've had a little bit of complaints from people going more, but it's more of the same. So we want to go find the angle that AG makes with BG. Oh, the BG's good band. Preferred ABBA, but anyway. So we're going to join A to G. That wasn't a very good join. I'll do it. I won't do it again because that stupid thing's in the way. A to G makes with B to G. So we want this angle here. Would we agree? We've got people turning their heads. Intriguing? So, well, let's have a look. If we look at that, what can you tell me if I join this up? What can you tell me about that triangle? Now, it looks like it's a Leaning Tower of Pisa, but I would say you know one of those angles. Hang on. I would say you know one of those angles. Yeah. Like the triangle where it splits at A would be 45. It looks like that angle at A could be 45, but no. It could be if it was a perfect sort of thing, yeah? Yeah? A, B? Would you agree that that is 90?
Yes.
If it's not, it means that the box is going to be, yeah, it's going to be coming out. My friend, that. We have the 12. Do we have the 8?
No, but that isn't that
We have the 8.
This is its own triangle here. So to get that, is that not the hypotenuse of this one? And you sort of might go, oh, groan. We have to use Pythagoras. Who could tell me what BG is without, or just from looking at it? I was going to say without using Pythagoras. Technically, you are using Pythagoras. Yep. Aiden? Dave? Yeah, it's 10. Why is this 10? 3, 4, 5 triangle, and it's just a multiple of. So we know we've got the 3, 4, 5 triangle. Oh, that does not come out well. So if I double it, that becomes 6, that becomes 8, and that becomes 10. Clearly, if those were not nice numbers, 6, 8, if they were different, then if we call this, let's call it BG, would we agree that BG squared equals 8 squared plus 6 squared? And therefore, to get rid of the squared, we have to root it. So square root of 64 plus 36, last time I checked, that's square root of 100, and the square root of 100 is 10. So now, when I'm looking at, I've got that triangle left, I've got, oops, that's 12, that's 6. How can I find this angle? You do the thing. Thanks very much, Grace. What's the thing that we do? So people who are saying sine rule, cosine rule, that sort of stuff, I'm thinking more of the ratios as in our right angle, because they are right, it's a right angle triangle. So back to the basics. What's this? Opposite, and this is adjacent. It is tan. So we're going to go tan. Oops. So that was 6. It's meant to be 10. So 10. And I even switched up my opposites and adjacent. Bad, bad, bad. I'd like to say I did that deliberately. I did not. So therefore, we end up with theta equaling 192. Love it. So once again, we wanted to find the angle that DF makes with DB. Now look for, how do you make a triangle? Yes, I know, 3 sides. Where's my third orange side?
FB.
Yep, you're all pointing. Drop it down, FB. And you have to look, and I want you, when you're saying look for the right angle, I want you to picture what a decent box would look like. So where do we think our right angle has to be?
DBF.
Els? DBF, and she said it so beautifully too. DBF, otherwise it's not going to be perpendicular with the side. Agreed? So take a minute to look at that. So where am I going to put my unknown angle symbol?
FDB.
Right, and I've already used theta for part A, so I have to pick a different symbol than theta. You could put X, but we tend to use Greek letters as the angle. Now, Carolyn, you might go, yeah, I really don't like, I can't see that nicely. One of the things that you could then do would be to draw your triangle out, and then you can just see easily what information do we have on this triangle. In order to find an angle, we need at least 2 other lengths. Yes, my friend?
We have the 6 centimeters.
Right, 6 centimeters. So that's 6 there. And again, I was looking at my year 9s before when they were trying to do their surface area measurement. They couldn't actually see if the 6 was here. They couldn't realize that this was also 6 here. So I said, just write it, right? Label all your sides. No, they refused to actually put pen to paper. I don't know why. Yes, Leon?
The other length you use 5, 12, and 8.
Excellent. So here, that's a right angle there. We're looking at the base, and we've got 12 and we've got 8. So we have to find Y first. So go ahead, find Y. Now, what you are doing is, because we are going to now use this in our thing over here, you're going to leave this as 208 instead of putting it in your calculator and getting a decimal answer, right? Because we're using it again. You can go 4, yeah, so on your graphics calculators, remember it will come up as 4 root 13, because what it's done is it said what square number goes into 208, and it's 16. Okay, so 208, check it, 16 times 13 is the same as 208. That's what your calculator just spits out, so don't worry about it, take it as read, all right? As, yes, it's allowed. Okay, so if you've got graphics calculators, we're saying 4 root 13. If you don't have graphics calculators, you're leaving it as root 208, correct? We now want to find our angle. Lo and behold, we've got opposite over adjacent. We are done here. Tan is 6 over 4 root 13. How do I get rid of the tan?
-1.
Tan to the -1, which is the inverse of tan. Is that what you were going to say?
It's all just back to right angle.
Yep, yep. High stands on top of a hill. From a point, some distance from the base of the hill, the angle of elevation to the top of the tower is 32. So we're going to put 32, 13.2. Agreed? From the same point, the angle of elevation to the bottom of the tower. So we're going to go through different colour, okay, different colour. Thank you. Now, what is it that we're actually trying to find?
Of the hill.
Oh, my little goat or sheep is going to turn into an X now. There we go. Think there, but we do just want to move it along. So one of the things, yes, we're going, yeah, if you go straight down, we're going, yes, that is 90 degrees. And some of us go, oh my God, 90 degrees. Well, then it's easy. I can solve it all. But we're still in a little bit of a pickle, because the 42, that is not a right angle triangle there. With this little right angle triangle, the smaller one, we've only got an angle. And same with the bigger one, we've only got this angle and we've got part of a length. So no go. So then we're in desperation mode. And we go, well, what else could we do? Dave?
Can we
two angles and find the relative lengths of like point something of an angle?
I'm not really sure what you said then. Relative lengths and points of an angle. I'm sure you probably could, Dave, but let's try and go simple. If you're just going desperate, what information could I get from what I have at the moment? Yes?
You can find the top angle for the
Right.
perpendicular.
I could find this one here, which then allows me to find this angle here as well. Would you agree? So can you please do that on your diagram? Find this angle, and if you're looking at me funny, why should you be able to find this angle? Who can tell us? 180 degrees in a triangle, so at the moment I've used up 98.3, and this then means it is here. So 180 take 8.3 take 90 gives you 81.7, is that correct? So now, using the fact that this is 180 degrees in a straight line, what's this angle here?
That 98.3.
Can you remember that in future, that if I wanted this angle, I can actually add these two together? Did you know that? Exterior angles of a triangle.
You couldn't have given us this information.
Well,
before we tried to figure the
they're
other
saying I couldn't I give this information before? Well, and it's actually on the back. It's the last rule on that poster over there. But anyway. So this angle here is now 98.3. And I'm coming back to what is the point of this question, Leon? What are you doing?
trying to find the height of the
Love you so much. But we're doing this. Have you finished this? Are you able to do this? Then please pay attention. This is again, have that to stop. We're trying to find this length here, correct? At the moment, we've only got one angle of this right angle triangle. If we could find this length or this length, we could then easily find the vertical x value, couldn't we? So I'm focusing now on this top triangle, and I'm hoping I'm going to hear some ahs in a minute. Because if I just draw this top triangle out, look at the information that I have. Oops. This is 42. This is 98.3. Do we agree? Do I have this? What is it? Ooh, it's not 13.2.
You can do the side.
4.9.
It's 4.9, and this here is part of my bottom triangle. So if I could find this, I can't call it x, have to call it y. Can I find that length? How?
Get that.
I've got a known pair. I've got this pair here. Oh, how sad. I don't have that angle. But I do. Oh, and you know what? And now I go, what an idiot I am, because I could have just found this from the bigger triangle, could I not?
You totally could have. You've already got the
90 plus 13 is 103.2. So this would be 180 take, or 90 take, the 13.2, which is... So Fletch just asked, why did you make us do all of this other stuff? Well, because I do a lot of these questions left, right and centre, and sometimes that's what you have to do for other ones. But if you're stuck, you just put down as much information as you can to get to the point that you have, and you will eventually get there. And then we go, oh yeah, I didn't have to do that. Boom, could have. So yes, if I had been concentrating and going, oh yeah, bigger triangle, instead of asking people to pay attention who were not, it might have been easier. So concentration is a key factor. Hey mate, don't be sorry.
Well, I just like understand why you got the 4.9.
So this angle here, right? Or the 13.2 goes all the way across. It was from the angle of elevation from the bottom up to the top. So that whole angle there was 13.2. This angle here was 8.3. Yep.